Hi, I'm Dr. De Bruin, and this video is a run-through of how to answer a question about the ideal gas equation from the amount of substance topic for AQA A-level Chemistry. You know that this question is going to require you to use the ideal gas equation because I told you in the title of the video, and also you've been given the gas constant, but actually before we get to that stage, we need to think about the chemical reaction that's happening here. You know from your GCSE studies that when the alkali metals or the group 1 metals react with water, they make a metal hydroxide and they also release hydrogen gas. And that's what we're actually interested in this question. And you're able to produce a simple equation like this, which we're going to need in a little bit when we're working out our moles of hydrogen. Now, for any kind of quantitative chemistry question, there is almost always a mark somewhere for working out the moles of something. So even if you can't see your whole way through the question, you need to be looking at the data you've been given and saying, well, what can I work the moles out of? And realistically, you're either going to have some mass data that you can use or some concentration data. Well, here we've got mass data for our potassium, and that's pretty much the only useful thing we've been given. So we know that we're going to need this mass is Mr. Mole equation. And we're going to need to rearrange it to make moles the subject. So moles is going to be mass divided by mR. Now, strictly speaking, it's not mR because potassium isn't a molecule and it's not an ionic compound. So we're not using relative formula mass, we're actually using relative atomic mass. So that I don't need to calculate, I'm just going to get it from my periodic table. And in the A-level chemistry periodic table, potassium has a relative mass of 39.1. Now, I say it's useful, I've been given the mass of this potassium, but actually I currently don't have it in a very useful format, so we need to do something about that. So those 200 milligrams, we're going to divide by 1,000 to get 0.2 grams. And then we're going to use our rearranged mass is Mr. Mole equation to do 0.2, that's the mass, divided by 39.1, that's the relative atomic mass, and that's going to give us 0.005115 moles of potassium. So the next thing I need to do is use this equation that I've written myself to work out my moles of hydrogen. So this equation tells me that for every 2 moles of potassium, I make 1 mole of hydrogen. But I don't have 2 moles of potassium, I have 0.005115. So really I kind of want to think about this as a ratio. So I've got twice as much potassium, I've got half as much hydrogen. So what I need to do to work out my moles of hydrogen is to divide this number by 2. And that's going to give me 0.00025575. And then from there, I'm now going to start using my ideal gas equation. So we've recalled this equation, but before we can substitute, we need to do a couple more conversions. So we need our pressure to be in pascals, which is going to be 100,000 pascals. And to work out the temperature, we need to add 273 to put it into Kelvin. And those two conversions together are worth 1 mark. And you can pretty much guarantee every ideal gas equation you get a mark for doing those two conversions. So I quite like the predictability of it. It's good. So we can then rearrange our ideal gas equation to make the volume the subject, and then substitute in the moles of hydrogen that we just worked out, the gas constant, the temperature that we've worked out or we've converted, and the pressure that we've also converted. So then if I do that calculation, I get a really long string of data. You don't have to write down all of those numbers, but you know, you're going to keep them all in your calculator. You're always going to use your full calculator display. But of course, our question asked us to give this in centimetres cubed, not in metres cubed. So now I'm going to do a conversion here as well. Hopefully you know to multiply by 1,000,000, but if you're under pressure, it might be worth just remembering where that million comes from. So you'll see here I've written it as 100 cubed, and that's because you know that to go from a number in metres to a number in centimetres, you multiply by 100. There are 100 centimetres in a metre. So to go from metres squared to centimetres squared, you multiply by 100 squared. And to go from metres cubed to centimetres cubed, you multiply by 100 cubed. And that's going to give me 62.27187 centimetres cubed. And then the final thing that I need to think about is that actually all the numbers I've been given in the question are to 3 significant figures. So my final answer is also going to be to 3 significant figures. Thank you very much for watching, and I hope that you're finding these walkthroughs of A-level chemistry exam questions useful. If you are enjoying them, then check out the playlist with all of the videos in, and don't forget to like and subscribe for more A-level chemistry content coming soon.